All right, guys, Mr. Antonucci here. And in this video today, I want to work through an example using Euler's method. Now, Euler's method is an approximation method to approximate solutions, particular solutions to initial value problems. Now, usually the case is you'll have an initial condition, a given point, a differential equation, and often they'll give you a step size or a delta x or a change in x, and they'll ask you to approximate another function value. So in this example, we're going to use Euler's method with step size 0.2. When you see this phrase step size, that's talking about delta x. So delta x in this problem is 0.2, and we're going to use that to approximate the value of f of 3. Given that, f of 2 equals 1. Now this f of 2 equals 1 is just your initial value. That's your initial point. That's your starting point. And dy dx equals x minus 2y. Now notice we have a differential equation here in terms of x and y. So up to this point, we haven't discussed methods for how to anti-differentiate differential equations that involve x and y of this kind of form. We don't need to do that. We have enough information here to use Euler's method. Now, with Euler's method, since the step size is 0.2, that's how much the change in x is, and you're trying to go from x equals 2 to x equals 3, you know that's going to be 5 steps that you're going to do. Now, Euler's method is what we would call an iterative process. That means you take the answer from one step to use that to then get the answer for the next step, and so forth and so on, until you are all done with the problem. So by far, the easiest way that I have found to do an Euler's method type problem is to set up a table of values to keep yourself organized and to bust out your calculator to calculate the values. So notice there's 5 columns in this because there's 5 things that we are dealing with. We're dealing with the initial point, we're dealing with the value of the slope, we're dealing with the change in x, we're dealing with the change in y, and then this is going to be our new point. And we'll explain that in a second. Then I put 5 lines here because we're going to do this process 5 times to get to f of 3. So in this first column, we start with the initial x and y, which is the point. Let me switch to red here, 2, 1. And then we use our differential equation. It's x minus, it should have a 2 there, and x minus 2y. So all you do is substitute the values of x and y into your differential equation. I'm going to show you on the calculator here really quick. All you do is x minus 2 times the y value. Now you could have done that in your head, but in this case, it's 0. Then the value of delta x. This is always going to be the same. It's always going to be 0.2 for this problem because they specified that the step size is 0.2. Now you might have a different problem where the step size is 0.1, could be 0.5, could be 0.01. They'll specify the step size for you. Resist the temptation to fill this whole column in at once. It's all going to end up being 0.2 because that's always what the step size is. It's that constant 0.2. That's not going to change. Okay, but you want to do this one line at a time. Now, to get the change in y, the change in y is approximately the slope times the change in x. So we get the slope from our dy dx, which we found to be 0 in this line, times change in x. And just to be consistent, we're going to do 0 times 0.2. Obviously, that's going to give us 0, but that's our change in y. Now, that's okay. Now, to get our new point, you take your initial point, add your delta x to the x, add your delta y to the y. You're going to get 2.2, comma, 1 plus 0, obviously, is 1. Now, all you do, this is your new point now. Notice the x value is 2.2 because we've gone a step size of 0.2. You take this point and just copy it down to the next line, and that becomes your new point, your new starting point. And this is usually when things begin to get interesting. So we take the x value to 0.2 minus 2 times the y value, because that's the formula for this slope, and you get 0.2. And that's okay that it's the same as 0.2, our delta x, but that is our slope. Now, to get the change in y, you multiply dy dx times the change in x. So just 0.2 times 0.2, which is going to be 0.04. And now you just add your delta x onto the x for that line and your delta y onto the y for that line. So 2.2 plus 0.2 is going to be 2.4. And 1 plus 0.04 is going to be 1.04. And then you just carry this process on. The next line is going to be 2.4, comma 1.04. Our slope is going to be 2.4 minus 2 times 1.04. And that gives us 0.32. Our dx, or delta x, excuse me, is always 0.2. And then our delta y is going to be dy dx, that 0.32, times delta x, so 0.32 times 0.2, and that gives us 0.064. Now, our new point is going to be the previous point plus the change in x for the x value, so 2.6. And then it's going to be the previous point, 1.04, plus the delta y, 0.064. And you get 1.104. Okay, now we just keep carrying on. You have to be careful, and this is the power of doing this in a table like this, because you have all your information laid out in front of you. All right, so now our dy dx, clear some of this off, is going to be our x value, 2.6, minus 2 times 1.104, 0.392. Our delta x is always going to be 0.2. And then to get our delta y, you just multiply these two previous values. So 0.392 times 0.2 gives us 0.0784. Now our new x is just the previous x plus our delta x, which is 0.2, so you get 2.8. We're close. You can see the next line, we're going to get our answer. And then our new y is the previous y, so 1.104 plus 0.0784, and you get 1.1824. Okay, so then that becomes the new point, so 2.8 comma 1.1824. And then our dy dx is the x value, 2.8, minus 2 times the y value, 1.1824. And that gives you 0.4352. Our delta x is 0.2. And so you multiply those together, 0.4352 times 0.2, 0.08704. Now, word of caution at this step. I know we have several decimal places. You want to go out as many decimal places as you can until you get to your final answer. So now the new x value is going to be 2.8 plus 0.2, or 3, and the y value is going to be 1.1824 plus our delta y, 0.08704, and that gives us 1.26944. And so to answer the question, we are done now. You don't need to do a new line with 3 because you are at the point when x equals 3. So to answer our question, f of 3, now I'm going to put wavy equal signs here because we're approximating the value of f of 3 as 1.26944. And that, ladies and gentlemen, will be your answer. And it's at this step that you could round. If you're taking the AP exam, you'd round to 3 decimal places. You could either round it or chop it off. So 1.269. You could put more decimal places if you want, but if your assignment or your teacher is asking you for a specific rounding place value, make sure you round to that specific place value. All right, guys, I hope that helped you out with calculating Euler's method approximations. I think using this table helps keep you organized and keeps you from making many mistakes. If this was helpful to you, please do subscribe to the channel and hit the bell for notifications, and comment below. Let me know if you have any math problems that you'd like me to make a video about, and maybe I'll do it. All right, guys, take care.